Okay.
Now, when we study chemistry, there are some things we need, right? Like when we study the physical chemistry, we need calculators, okay, to solve some problems. When we study inorganic chemistry, we want periodic table, right, to basically write the electronic configuration. So here we are starting with the group 2 chapter. So you need periodic table. So do you have your periodic table with you?
Yes, ma'am.
Okay. So let's get started. So chemistry is a very easy subject. Do you love chemistry?
Yes, ma'am.
Okay, that's great. What we are going to study today is that what are alkaline earth metals, that is also known as your group 2 metals. Their natural occurrences we will study. Their position in the periodic table we will see. Electronic configuration, the physical properties, atomic and ionic radii, ionization energy, and uses of alkaline earth metals. So I hope you have heard of these terms, like ionization energy, atomic radii in your lower level. So let's get started. So there are two groups, okay, group 1 and group 2. If we study the S block in your periodic table, then we have two blocks. One is your group 1 and one is group 2. Group 1 metals are called alkali metals, okay, and group 2 is called your alkaline earth metals. So many students here get confused in this, that ma'am, alkali and alkali metals are same or they are different. They are completely different. I mean, they are same, like both are S block elements, right? Both electronic configuration of both of them, they end in S orbital. Okay, for group 1, if you see it in your periodic table, it ends like this. For if we study for lithium, then what is the atomic number for lithium?
3, ma'am.
Yes, it is 3. So what do we write as the electronic configuration? 1s2, 2s1, right?
Yes.
So here we have, you can see that the outer electron is lying in the s orbital. But if we see the next element, that is beryllium, which atomic number is 4, it is 1s2, 2s2. Here also the last electron is lying in the s orbital. So yes, they are alkali, they are s block elements, but in the group 1 metals, your only one electron is filled, but in group 2 metals, both the electrons are filled in the s orbital. Got it? So this is a list of your alkaline earth metals. You have to remember beryllium, magnesium, calcium, strontium, barium, and radium. And in chemistry, the chemical symbols are also very important, because in sometimes in your examination they will give you only Ca. So you have to assume that we are talking about calcium. Ba is barium. Be is beryllium. Okay, so you have to remember these 6 elements, alkaline earth metals, and their symbols. So write it down in your notebook.
Yes, ma'am.
Done writing?
Yes, ma'am.
These are some uses of your alkaline earth metals, right? Is given here. Their natural occurrences we will study. Where do they find? Where do they occur basically? They occur in your earth crust. That is why in their name we have earth, right? Alkaline earth metals. Why earth? Because they are found in the earth crust. In the rock structures also, magnesium, it is found in carnallite. Carnallite is a ore, okay, from which your magnesium is profitably extracted. It is, you don't need to remember the formula, but let me tell you, it is KCl.MgCl2.6H2O. So this is an ore where all these elements are made, from which you can extract magnesium profitably and conveniently. Okay, magnetite ore, dolomite, they are the names of ore. What is ore? Ore, from ore you can extract the metal. Okay. Now if we talk about calcium, it is found in chalk, limestone. Limestone is, do you know the chemical formula for limestone? Calcium carbonate. Okay, limestone is calcium carbonate. Gypsum we have, gypsum is important. You can write down CaSO4.2H2O for gypsum. Anhydrite means when you remove the water from gypsum. Okay, so from this we can extract calcium easily. Write it down.
Yes, ma'am.
Now this is the periodic table. You have this is the structure of the periodic table. It is divided into 4 blocks depending on where the last electron goes to. For example, this is known as group 1. This is known as group 2. So can you tell me how many groups are there in the periodic table?
8, ma'am.
But when you study your like you are in A level now, so you will tell that groups are 18. Okay, we count the groups of this D block elements only. Also, so it is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 groups in the modern form of periodic table. And how many periods are there?
Ma'am, 7.
Yes. There are 18 groups and 7 periods in the periodic table. What do group 1 is called as?
Alkali metals.
And group 2 is called as?
Alkali earth metals.
Very good. Okay. So here we are focusing our studies only to a group 2, that is beryllium, magnesium, calcium, strontium, barium and radium. So this is the trick to learn the alkaline earth metals if students don't remember it. So we have a trick. Big mice can scare brown rats. You can see the first alphabet is matching with the element name. So you can easily remember that C for can and C for calcium. So you can write down this trick.
Yes, ma'am.
Okay. There is a very important note here. So many students don't know this, but as you are an intelligent student, so you should know that beryllium is not an alkaline earth metal. Beryllium, as we have studied beryllium, magnesium, calcium, strontium. What next?
Barium.
Next.
Radium.
Very good. These are known as your group 2 metals, but from here, beryllium is the only metal which is not an alkaline earth metal. Why it is not an alkaline earth metal? Because beryllium oxides and beryllium hydroxides, they are not alkaline. Okay, otherwise all the elements oxides and hydroxides are alkaline in nature. But beryllium oxides and hydroxides are amphoteric in nature. Amphoteric means they show both acid character as well as basic character. Show both acid and basic character. Okay. So why beryllium is not an alkaline earth metal? Because its hydroxides and oxides are not alkaline in nature. They are amphoteric in nature. So this is an exception. Write it down.
Yes, ma'am.
So where are the alkaline earth metals in the periodic table? Elements in the group 2 on the left of the periodic table are called alkaline earth metals. Okay, so by now I think you've got you have learned this, right? Beryllium, magnesium, calcium, strontium, barium, radium. Why they are called alkaline earth metals? Because their oxides are because of their oxides. They are alkaline in nature and also they are obtained by electrolysis of the molten earth. That's why the name earth in the alkaline earth metal. Okay, electrolysis means breaking down of a electro means electricity. Okay, and lysis means breaking down. So you break down a compound into its elements by passing electricity. Okay, so they are obtained by electrolysis of the molten earth and they are called alkaline earth metals because their oxides and hydroxides are alkaline in nature. Write it down. Alkaline means, what does the word alkaline means?
Water soluble bases.
Yes, very
Yes, ma'am.
Can you answer this question?
Ma'am, aluminium.
Good. Now, S block elements. In S block elements, we have group 1 and group 1 is called alkali metals and group 2 is alkaline earth metals. So in group 1, we have Ns1 electron and group 2 is Ns2. What is N? N is the principal quantum number. Okay, so basically it tells you about the energy of the metal. It is the size. It tells us about the size. For example, lithium. If we talk about lithium, so it is atomic number is 3. We write it as 1s2 2s1. Okay. What comes next after lithium? Tell me.
Ma'am, beryllium.
After lithium? No. After lithium in the group, not in the period. Like vertical downwards. Sodium, right?
Yes, ma'am.
This is the atomic number of sodium.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Ma'am, 12.
So it is 11. For sodium, it is 11. So we write it down 1s2, 2s2, 2p6, 3s1. So this 2, this 3 is the value of N. Then we have studied that all the reactive metals with low ionization energy. Why they are reactive? Because they have only one electron in their outermost shell. Okay, and every element wants to achieve stability. They want that they lose their electron and wants the outermost shell to be completed by 8 electrons. So they are reactive metals. Why they have low ionization energy? Can you tell me what is the meaning of ionization energy?
The energy that is required to remove one electron in its gaseous state to form a gaseous ion.
Yes, very good. So it has very low ionization energy because as I told you that this outermost electron it wants to remove from here easily, right, to complete the stability. It loses outermost electrons readily to form 1 plus ion or 2 plus ion. They are highly reactive. That's why they always react with other substances. That's why they are never found pure in nature. They are always found in the reactive state. Got it?
Yes, ma'am.
Write it down.
Yes, ma'am.
If we talk about alkaline earth metals, then they are group 2 elements with outermost electron. How do you define alkaline earth metals? So this is the definition. That they are group 2 elements with outermost electronic configuration of NH2. And the first element, beryllium, it differs from the rest of the members and shows diagonal relationship to aluminium. Diagonal relationship, if you see in your periodic table, you can see that beryllium and aluminium, they are diagonally placed, right? So it shows a diagonal relationship with aluminium means that most of the properties of beryllium they matches with the properties of aluminium. Okay, why it is so? Why beryllium is different? Because of its small size, because of its high charge density, and because it can form which type of oxides? Amphoteric oxides. Also, it is covalent in nature. So these are the different properties as compared to other elements of your group 2. Okay. Write it down.
Yes, ma'am.
Yes. Okay. So can you answer this question?
Ma'am, A.
Magnesium is called alkaline earth metal because magnesium oxide and hydroxide are alkaline and magnesium oxide is found in the earth crust. Now let's move on to the electronic configuration. So as I told you that they have 2 valence electrons. So there is NS2 outermost electronic configuration. So for beryllium it is 1s2 2s2. For magnesium, it is 3s2. For calcium, it is 4s2. For strontium, it is 5s2, and so on. Okay, so for radium, it becomes so long to write down the electronic configuration. That's why we write it as radon 7s. Okay, radon is your nearest noble gas, okay, whose atomic number is 86. So we just write the shorthand electronic configuration of the noble gas. Okay,
Yes, ma'am.
you want to write it down?
Uh, okay. Yes, ma'am.
Okay. Here you can see that this is the shell number. Okay, shell number means, as you know, the atomic structure, that we have a nucleus in the center of the atom which is positively charged, and these are my shells. Okay, so if shell number is 2, then it is beryllium. If shell number is 3, it is magnesium. Shell number is also known as period number. If I ask you the question that in which period your barium will lie, what do you answer?
Period 6, ma'am.
Yes, very good. Write it down.
Yes, ma'am.
Now we are going to learn about the physical properties of group 2 elements. The first property, physical properties means that how they appear, okay, like all these without changing the chemical identity, they are just checking the properties. So it is silvery white, soft, but they are harder than alkali metals. You know that some alkali metals like sodium and potassium, they are so soft that they can be cut with a knife. You can even cut them with a knife. They are so soft. The alkaline earth metals, they are harder than alkali metals. They are lustrous. Lustrous means
I don't know, ma'am.
lustrous means that they are shiny. Okay, these are the properties of metals. They are malleable, they are ductile, and they are lustrous. Shiny. Melting point and boiling point, they are higher than alkali metal. Why melting point and boiling point are higher than alkali metal? Because of their small size. Do you know that when we move across the period in the periodic table, then what happens to the atomic size?
It increases, ma'am.
Yes, atomic size decreases. Okay. So they are smaller in size. That's why melting point and boiling point are higher than alkali metal. They are strong electropositive in nature. Electropositive means they can easily lose their two electrons to achieve stable noble gas configuration. Electronegative means tendency to attract the shared pair of electron towards itself. And electropositive means tendency to donate the electron. Calcium, strontium, barium, they impart characteristic brick red, crimson, and apple green color respectively in the flame. So this is a word what we call as flame test. Okay. So in the flame test, what we do that your electron that in the Bunsen burner, when energy is supplied, then your electrons they rise from the lower energy level to the higher energy level by taking the energy, by absorbing the energy. And when they return, they emit the radiation. They emit colors. When they return, then they emit radiation of suitable frequencies. So in that, your calcium will give us brick red color, strontium will give crimson color, and barium will give apple green color. So these colors are important for you to learn. Okay, so write it down.
Yes, ma'am.
What is electropositivity and how does the electropositivity affect your elements? So due to their large size, we are comparing it with your what we call as alkali metals. So we are comparing it with alkali metals that due to their large size and comparatively low ionization energy, they are strong electropositive elements. So this question will land up in your exam. Why group 2 elements are highly electropositive? What should be the reason? Because they have low ionization energy and their atomic size is also large, so they can easily lose their electrons. And on moving down a group, electropositive character increases. So if I ask you that which one is more electropositive. And if I give you the option, like so what do you answer?
Ma'am, calcium.
Calcium. But it is written that electropositive character increases down the group. Then
Barium, ma'am.
barium, right?
Yes, ma'am.
Write it down.
Yes, ma'am.
Okay.
Yes,
To
ma'am.
talk about the physical properties, then they have higher melting points, are harder and more denser than potassium and sodium, right? Then when put in flame, magnesium is white in color. So basically you don't need to write this line because we'll study that beryllium and magnesium, they do not impart any color. Okay, they do not impart any color to the flame. Calcium is dark red, they do not impart any color. Reason we will see in the next slide. They have two valence electrons. They are metallic, obviously. All the group 1 and 2 elements are metals. They are ductile. Ductile means their property to be broken, to be hammered, to be beaten into thin sheets, right? Property of a metal. Sorry, thin wires, I think. Yeah. For ductility, property to be beaten into thin wire. Like copper, right? Shiny, silvery white. Malleable means hammered into thin sheets. For example, gold, silver, okay. So these are some physical properties. Can write it?
Yes, ma'am.
Okay. Next is your atomic and ionic radii. So what is the definition of it? That distance from the center of the nucleus to the boundary of the surrounding shells of electrons is already you know atomic radii. Now let us compare with the alkali metals. That alkaline earth metals, they have sizes smaller than alkali metal but larger than other element in a particular period of the periodic table. Because you know the trend. Here the atomic size decreases, but here the atomic size increases. Okay, so here it is written that atomic and ionic radii of alkaline earth metals increases on moving down the. Okay, write it down.
Ma'am.
Okay. So this is the trends in the atomic radius. That atomic radius of group 2 elements, they increases going down the group. The reason is important because each element's atom going down the group has an additional full energy level compared to the one above. So this gives the weaker nuclear forces of attraction. Okay, so you can see the sizes in the group 2 alkaline earth metals. Why it increases going down the group? Because you have studied it is 1s2, 2s2, 3s2. That means your principal quantum number is increasing, so not shell out. Write it down.